Good morning, everybody. Today we shall continue the chapter Matter in Our Surroundings. In previous class, we shall discuss about the how particles of matter attract each other, states of matter. States of matter. We shall discuss about properties of solids, liquids, and gases, and then change of state. Okay, dear students, today we shall discuss about the importance of melting, boiling, and the effects of change of pressure and sublimation. So here, melting. So you have here the name of the melting. Yes, you have here the name of the melting point in your previous standards. So here melting points means when a solid is heated, the particles begins to vibrate with greater speed and begins to move more freely. Then at a particular temperature, the solid melts and changes into liquids. So this process of melting is known as fusion. So here when a solid is heated, the particles begins to vibrate with greater speed and begins to move more freely. So then at a particular temperature, the solid melts and changes into liquid. So this process of melting is also known as fusion, or the temperature at which a solid melts is called melting point. So note down the point here, students. What do you mean by melting point? Here melting points means the temperature at which a solid melt is called melting point. So the melting point of ice is 0 degree Celsius or 273 Kelvin. When we see the melting point ice in Celsius is 0 degree Celsius. When you see in Kelvin, here 273 Kelvin. The melting point of Kelvin is 273 Kelvin. The melting point of ice in Celsius is 0 degree Celsius. And then latent heat of fusion. Here, latent heat of fusion means the amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is called latent heat of fusion. So once again I am repeating here, latent heat of fusion means the amount, here observe the figure, the amount of heat energy required to change of 1 kg of solid into liquid at atmospheric pressure at its melting point is called latent heat of fusion. Here question is arising in this topic. Here what is melting point? So what is the temperature of the melting point of ice in 0 degree melting point of ice, and what is latent heat of fusion? And then boiling. So here when a liquid is heated, its particles begins to move even faster. Then at a particular temperature, the liquid begins to boil and changes into gas or vapor. Here boiling means here. So when a liquid is heated, when a liquid is heated, its particles begins to move faster. Then at particular temperature, the liquid begins to boil and changes into gas or vapor. Here boiling is a bulk phenomenon. Boiling is a bulk phenomenon. When a liquid boils, the bulk of the liquid changes into vapor. The temperature at which a liquid starts boiling is called boiling point. The temperature at which a liquid starts boiling is called boiling point. The boiling point of water is 100 degrees Celsius or 373 Kelvin. Here question is arise, what is boiling point? What is boiling point? Here boiling point means the temperature at which a liquid starts boiling is called boiling point. And what is the boiling point of water in Celsius? The are Kelvin. The boiling point of water in Celsius is 100 degrees Celsius and in Kelvin is 373 Kelvin. And then latent heat of vaporization. Latent heat of vaporization. The amount of heat energy required to change 1 kg of solid into gas at atmospheric pressure as its boiling point is called latent heat of vaporization. Here, carefully observe here and note down the point. What do you mean by latent heat of vaporization? Here, latent heat of vaporization means the amount of heat energy required to change 1 kg of liquid into gas at atmospheric pressure as its boiling point is called latent heat of vaporization. So here see the effects of temperature on molecular motion in solid, in cold. So we have to see the molecular motion in solid. Here the in cold and in hot, and same as in liquid and the liquid in cold, in hot. Effects of temperature on molecular motion. And then sublimation. So this topic is very important in your examination, and diagram is also very important in your examination. Here sublimation. So let us know what in this topic we shall discuss about. So what is sublimation? So what are the importance of the sublimation? So sublimation means the change of state directly from solid to gas without changing into liquid. So it is called it as sublimation. A change of state directly from solid to gas without changing into liquid is called sublimation. So how sublimation will take place? So let us see through the activity. Dear students, observe this figure. So here set up the operators as shown in the figure. So here which operators we have to take it? Here cotton, inverted funnel, ammonium chloride, ammonium chloride solidified, china dish and burner. Here take some camphor or ammonium chloride. Take some camphor or ammonium chloride, crush it and put in a china dish. So take some camphor or ammonium chloride, so crush it and put in a china dish and put an inverted funnel over the china dish. Put an inverted funnel over the china dish and put a cotton plug on the stem of the funnel. Put a cotton plug on the stem of the funnel. So now heat slowly and observe. What do you infer from the above activity? So what we have to observe then? So we have observed that a change of state directly from solid to gas without changing into liquid state. So that's why it is called it as sublimation. So that's why it is called it as a sublimation. So very important in your examination. And then effects of pressure on gas. Effects of pressure on gas. So we have already learned that the difference in various states of matter is due to the difference in the distance between the constituent particles. So what will happen when you start putting pressure and compress a gas enclosed in a cylinder? Will the particles come closer? Do you think that increasing or decreasing the pressure can change the states of matter? So here, by applying pressure, the particles of matter can be brought close together. By applying pressure, the particles of matter can be brought close together. So applying pressure and reducing temperature can liquefy gases. When you apply, so observe these three figures. So here, so when we observe the figures, when piston piston is moved, when force is applied, here the particles are come close together. So here when pressure is applied, here the particles are come close together. So you heard of solid carbon dioxide? You heard the solid name of the solid carbon dioxide? So it is stored under high pressure. Solid carbon dioxide is stored under high pressure because solid carbon dioxide gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. Here note down the point. Here solid carbon dioxide directly converted into gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. So that's the reason that carbon dioxide is also known as dry ice. Carbon dioxide is also known as dry ice. Dry ice. So we can say that the pressure and temperature determine the state of the substance, whether it may be solid, liquid or gases. When pressure is applied on gas, here observe the figure. Through the piston, when pressure is applied, the particles are the particles are come close and the gas changes into liquid. We can liquefy gases by applying pressure and reducing the temperature. So compressed solid carbon dioxide is called dry ice. Here question is what is dry ice? Here dry ice means compressed solid carbon dioxide is called dry ice. If the pressure is reduced, it changes directly to gas without coming into liquid state. So solid carbon dioxide is known as dry ice. And then so interconversion of three states of matter. So you have to see here the states of matter are interconvertible. The states of matter can be changed by changing the temperature or pressure. The states of matter are interconversible. The state of matter can be changed by changing the temperature or pressure. You have to see that the interconversion of matter. So here when solid is heated, it can be changes into liquid state. When liquid is heated, it can be changes into gaseous state. When gaseous is heated, it changes into when gas is cool, it changes into liquid state, and liquid is cool, it can changes into solid state. So that's the interconversion of the three states of matter. And then evaporation. Here evaporation means the change of a liquid into vapor at any temperature below its boiling point is called evaporation. So all of you heard the name of the evaporation. So here evaporation means the change of a liquid into vapor at any temperature below its boiling point is called evaporation. Evaporation is a surface phenomenon. So particles from the surfaces gain enough energy to overcome the force of attraction and changes to vapor state. So evaporation is a surface phenomenon. Particles from the surface, here observe the figure how evaporations will be and takes place. So here it is a surface phenomenon. Particles from the surface gain enough energy to overcome the force of attraction and changes into vapor states. So what are the factors of evaporation? Here factors affecting evaporation are the rate of evaporation depend upon the surface area, temperature, humidity and wind speed. Here note down the point here. Here the rate of evaporation depends upon the surface area, temperature, humidity and wind speed. When increase in the surface area increases the rate of evaporation. So increase in temperature increases the rate of evaporation. And increase in humidity decrease the rate of evaporation. And increasing wind speed increases the rate of evaporation. Are the factors are affecting on evaporation. Once again I am repeated. Here the rate of evaporation depend upon the surface area, temperature, humidity and wind speed. When increase in the surface area, increase the rate of evaporation. Increase in temperature increases the rate of evaporation. Increase in humidity decreases the rate of evaporation. Increasing in wind speed increases the rate of evaporation. So here evaporation causes cooling. Evaporation causes cooling. So when a liquid evaporates, the particles of the liquid absorb heat from the surrounding and evaporates. When a liquid evaporates, the particles of the liquid absorb heat from the surroundings and evaporate. So the surroundings become cold. For example, people sprinkle water on the roof or open ground because during evaporation water absorbs heat and make the hot surface cool. So you have understood? So people sprinkle water on the roof or open ground because during evaporation water absorbs heat and make the hot surface cool. Same as during summer we sweat more because during evaporation the sweat absorbs heat from our body and making the body cool. During summer we sweat more because during evaporation the sweat absorbs heat from our body and making the body cool. So, and another examples are we wearing the cotton clothes. Why we wearing the cotton clothes in summer? So, when we wearing the cotton clothes in summer, it keeps us cool because cotton absorbs sweat and when the sweat evaporates, it absorbs heat from our body and making the body cool. So, that's the reason we wearing the cotton clothes in a summer. Okay dear students, today we shall discuss about the importance of sublimation and effects of pressure on gases and inner conversion of three states of matter, evaporation and factor affecting of evaporation and evaporation causes cooling. Okay, thank you. Next we shall discuss about the second chapter, is matter around us pure? Okay, thank you.